Ladies and gentlemen, someone is wrong on the internet, and here we are to explain why. So, I'll leave you a little bit of background about this real quick. A gentleman named Neocon Mint, who is kind of famous for always being on the wrong side of like every issue. He in the past had dialogue with actual biologists, trying to explain to them that DNA was code. And the biologists were trying to explain that no, DNA is biological information, but it's not a code. If you want to argue something's a code, try to argue something along the lines of RNA synthesis codon charts. Sure. Want to call it a code? Great. Doesn't get you to intelligent design. But he's always arguing things that are wrong. And so one of the things that you simply cannot argue, one of the things that is simply just not debatable, more so than even the shape of the earth or the age of the earth, is math. Because math could be proven. So I have formally challenged him on Red's Rhetoric's channel to go on and have a discussion on Red's channel about this topic. I don't think he's gotten that yet, but I was going to kind of go through what he's written to me about this with his permission. He said I could, and explain why he's fractally wrong. And no, we're not dealing with fractals, although that would be really cool. But we will be talking about fractions, however. And he keeps messaging me every single day saying, Steve, you're an idiot. Steve, you don't know basic math. Steve, you're a moron. And here I have Cyrus with us, who is a well-known, soon to be well-known person on the internet with his channel. He's getting up there. He was pretty smart. And I also got Landon Curtinol, who's probably one of the foremost leading computer scientists in the freaking world. And he's also very good at math, because that's what he does. And I think between the three of us, we can actually show unequivocally that Neocon Mint is just a moron. And I don't even know where to even begin at all the issues that he has are wrong. But I don't know why Jared is not a Jared. Let me get you a mod here. You can be a mod. There you go, Jared. So he's in the live chat upset. He's not a mod. I made you a mod. Yes, Leonard.
Math can prove he's wrong. It can't prove he's a moron.
This is true. That's a subjective evaluation. Yes.
His being wrong and insisting on being wrong is moronic. But I just, there's a limitation to math, and math can't prove someone's a moron.
I definitely agree.
Math can't prove you're a moron, but your methods can prove you're a moron. And if your methods involve math, then that's fine with me.
I agree. And by the time we get done with this, I'll take a little sampling of the live chat and see if they agree that Neocon Mint is not a person you really want to go get math information from. And by the way, we all make math boo-boos. I made some huge math mistake the other day dealing with infinite probability distributions, and Dr. Rachel Traylor called me out, and she was right. But I know enough to go, fuck, I was wrong. Oops, forget what everything that I just said, and move on with my life, right?
I mean, let's be honest, you also were in the nuke program where if your math was wrong, people might die, or you might not have weapons at all.
Yeah, it's pretty important to get the math right. Matter of fact, my biggest error that I would make continually in nuke school was that I always forget, for some reason, to carry forward a minus sign. So I'd get the right answer. Well, it wouldn't be right because it would be obviously a positive versus a negative or vice versa. But conceptually, I had it all right. I understood the material. It's just for some reason I would make a minor mistake. And they don't count that heavy off for that. If they realize that you actually understand the material and you just make a minor error and you carry that error all the way through, you at least get partial credit. And I think that's a good way of doing it, because that it shows that at least you do understand material. So anyways, let's jump right into it. Let me start by screen sharing what I have here. Then we'll kind of actually show the math. And this is what he actually wrote to me. I've actually put it on a document WordPad, so I don't show anything that he didn't want me to show. This is what he's actually said I can show. So this, and I don't need cameraman, but I'm going to turn on anyways. Let me do that real quick, just in case somebody does get the link. I don't know how, but whatever. Better safe than sorry. All right. So can anybody outside chat read this? If not, I can make it larger, but it looks pretty large to me. Can you guys read that? I know it might be difficult for you to land in.
Okay, yes. I
okay.
can read it.
Now, these are his words. So let's just kind of start off, and Landon, as we go through it, maybe you can point out why this is incredibly wrong. He says, math is based on numbers. Okay. Okay, we agree. Starting with equally spaced markings on an infinite line by whole numbers. Between those markings, symbolized by decimal numerals, there are still values presented as percentages or fractions. A whole number, like 1, is a number without a fraction, and one way to write a fraction is to place a period between the whole number and the fraction. Numbers can contain whole numbers separated by a period followed by fractions. The number 0.9 repeating contains 0 whole numbers and a fraction. Okay, that's the point where it just starts to go off the rails.
By the way, could I didn't know if you wanted me to
Yes, please.
He said, math is based upon numbers. I mean, that implies that math requires numbers. I think there's a number of mathematicians that are saying, I deal with things that are not numbers. Like an algebraic topologist might differ and say, no, I do math and I don't have anything to do with numbers.
I would also argue logic falls under mathematics too.
Yeah, so mathematical logic is not necessarily based upon numbers. In fact, you can construct numbers from axiomatic systems in mathematics. So this notion of math is based upon numbers. Maybe he's saying
if he said real mathematics, then I might kind of agree, like real analytics, maybe.
I mean, math uses numbers, or
mathematics requires numbers, but it's not the same thing as math is based on numbers.
Yeah, I agree with that. I don't think it's a correct statement either. I think that the logic way of doing mathematics is far more critical to mathematics than just numbers. You don't have to have numbers to do math.
So he says starting with equally spaced markings on an infinite line by whole numbers. Okay. Now, math actually doesn't construct the number line that way. Right? You don't say that's a visual representation of the integers, but it doesn't start with that, right? So the math is based on more than just numbers. It doesn't start with equal space markings on a number line. That's your mental representation, and be careful about representation stuff. And it says between those markings symbolized by decimal numbers. Okay. First of all, decimal is just a representation number. The integers are integers regardless of what base we use. It doesn't necessarily mean decimal, right?
Right.
And you can have markings. There are still values represented by a percentage or fractions. Now that's wrong.
Oh, that's just totally wrong.
Because on that real number line, because I think what you're talking about is a real number line. And in real number line are the reals. That's actually, because you shouldn't say number line. The reals, which can be represented as a line, between fractions, there are infinite number of values that are not rational.
Correct.
And there are infinite values between the irrational numbers of things called transcendental numbers. And so the construction of reals are actually quite complex. And there are even complex numbers or a plane can be represented, but don't assume that numbers are integers, or numbers are base 10, or numbers are a number line.
Yeah, he's in that mindset that everything has to be based upon integers for some reason. And I think that's something that you would probably get out of by the fourth grade.
I mean, yes. So if I would sit there and say, and a better way to phrase it might have been to say, in mathematics, we can represent the integers, whole numbers, on a line, and we can assign symbols to those integers by using a base such as 10, as in the classic decimal system. That might be a less cringeworthy, but as I say in that paragraph, there were so many cringes that going by
I told you I didn't know where to begin because there's just so many things that are just wrong on here.
I think what he's trying to say in this first paragraph is, hey, the integers can be represented as points on a line that are equally spaced, and we have a notation base 10 that we can use to assign symbols to those integers. Don't confuse the symbol with the value. What do I mean by that? Right? When we write something like 3,
That's just a numeral, just a symbol representing a position on the real
Three.
line.
That's not the value 3. That's a symbol that we happen to use.
It represents it. Yeah.
You know, the common thing is you say, I'm having a symbol that is in base 10, and those are the coefficients of a polynomial in base 10, whose value is 13.
Yeah, I think a lot of people, they look at a specific thing and they see the symbology. They look at the numeral and they think that that is the actual number rather than a representation of where it lies on that real number line.
No, and as a philosopher, you run kind of this difference between the value and the thing.
Yeah, I see a distinction because I see one as a reference and one as a referent. One is a pointer, is an index to where you want to be on that number line.
Yeah, Landon is my name, but I'm not Landon. I'm me.
Right. Yeah.
13 is a representation of a polynomial. The value of 13 is independent of how I draw that, because different languages express digits differently, but it's the same value.
Well, that's like when you get that confusion whenever somebody says that, oh, well, numbers wouldn't exist if there weren't people to interpret them. It's like, no, the idea that those numbers represent is always going to be there, regardless of how you choose to represent the number.
Yes.
Yeah, I mean, there's some people that are more mathematical Platonists that thinks that somehow math exists on some kind of abstract plane of some sorts, but I think math is math, regardless if humans are around or not.
Yeah.
Conceptually.
And 13 is a value, whether you believe in it or not, as well.
Yeah. And even then, even not so much even dealing with polynomials, but if you just have something like cosine 0, that actually represents the number 1. If you say, you know, what is cosine 0, that is 1. They are equal to each other. And this is kind of the whole thing that he's missing. 0.99 repeating is 1. It's just cosine 0 is the same as saying 0.9 repeating. It'd be the same thing as equal to 1. They're all identical ways of just representing the same position on the real number line.
Because as 13, I could also represent as something like, I could say, for example, 10 plus 3, right? Now those are symbols.
Mm-hmm.
Say, take the value 10 and add to it the value 3 under the rules of addition, right? Using real numbers, right? And that's another, it's the same value, a different symbol. That's an important thing to understand. You can have the same value in different ways to symbolize, right? Just like you use a different base.
Mm-hmm.
You can talk about, I mean, because if we talk about, let's say, give you a value, for example, if I talk about something in hexadecimal, I say something like A. In hexadecimal, that's the same as decimal 10. It's just a different, so don't confuse, the value 10 is represented as A using the hexadecimal notation.
And sometimes these numerals aren't even representative of actual values. Like 1 and 0 can actually represent multiplicative identity or additive identity. So you can have actually 1 equals 0. It's called the ring identity. So, or the zero ring identity. So there are times that they don't even represent positions on the real number line. So you can't have 1 equals 0 on certain types of mathematics.
Well, you know what the best part about all this is, though, is that everything that you just said has documentation behind it that is easily accessed on the internet. And
well,
yet,
I think they think they're lying to them, Cyrus. They really think that Wiki is wrong because it's Wiki, or Purple Math is wrong because it's a web page.
I mean, they can always do this wonderful thing that me and a lot of other people in my community have learned to do with Wiki, is you scroll down to the bottom of the page, and there's this wonderful little area where it marks sources, and you can go check those individual sources, and you can see if the interpretation on the Wiki is right or not.
Yeah, and you can actually validate it with computational programs such as Wolfram Alpha, which I'm going to eventually do here. So what do you got written there?
But say not all symbols have values. For example, I have 1 divided by 0. Does
Undefined.
Not value in the real number space.
Right. Yeah, that doesn't exist anywhere. It's undefined.
Because classically, this division symbol is rules of division under the reals, and this symbol does not have a value in the real number.
The way the rational numbers are defined, which I'll get into, doesn't allow for a denominator to be 0.
Yeah. And so typically you say division is under the reals where the denominator is non-zero. Just like you also have something where you can sit there and say, square root of -1, that symbol has a value. It doesn't have a value in the reals. It happens to have a value in the complex numbers. But again, so symbols can reference things, and there are more than one symbol can reference the same thing. Just like we say 4 or 2 plus 2, they refer to the same value. They're two different symbols.
That's why I just look at them as references to the same object.
Yes.
That's how I look at it. Okay, so he says a whole number is like a number without a fraction, and one way to write a fraction is to place a period between the whole number and a fraction. I don't know what he even means by that. A fraction.
That's not a fraction. That would be a decimal.
Yeah, that would be a decimal. Fraction is literally you either need a horizontal bar or a solidus, which is a slash. So 1 over 2 is a fraction. A proper fraction is anything between 0 and 1.
Yeah.
Expressed that way.
2 divided by 1, it's a rational number, right? In fact, it's defined as a rational in the real because the denominator is not 0. And that's a perfectly valuable thing. And that also happens to be a whole number, right? So the symbol that we're 2 divided by 1 is a symbol that's used the same. This equals 1 plus 1 equals 2. I mean, all that is, when we put this equals, we're saying they have the same value.
Yeah, there's an equivalency. People get a misconception on the equal sign. The equal sign just means there's an equivalency between the things. It doesn't mean that every single property is exactly the same. And clearly, 1 plus 1 looks differently than 2. There are differences.
I have a lot of programmers or people that program languages where in programming you say A equals 1 plus 1, and the computer values 1 plus 1 and stores it in A. That's not what mathematics uses the equal sign for.
Right.
Programming language might say assignment, but in math, equal is equivalent.
Yeah, they're two different strings. In math, you can load it as a string.
Yeah. So the notion that this notion of fractions, I think what you're trying to refer to is those rational numbers that are not members of the integers, because all integers are rational, but not all rationals are integers.
Okay, so he also says the number 0.99 or 0.9 repeating contains 0 whole numbers and is a fraction. I don't know what that means by contains whole numbers, and why would you think that's a fraction?
I mean,
clearly it's not a fraction. It's not even in fractal form.
Numbers can contain whole numbers separated by a period. So first of all, he's again confusing symbols with values, right? I think what he's trying to say is, well, we have these symbols where what we typically do is we put a number separated by a period followed by fractions. I think he thinks, like if I have 3.5, this 0.5 is not a fraction.
No, it's a decimal.
It's
in the 1/10th place.
Whole number followed by a period followed by a fraction. By the way, in some places in the world, you use the decimal comma rather than the decimal point.
Sure.
So his notion of it being a period is also
wrong too. Yeah, 3,5 is sometimes in Mexico, for example. I believe they use a comma for a does. Zero, real quick. Zero ask Landon if he agrees that a repeating decimal notation is just shorthand for a limit.
Yeah.
Yeah, because that's how I'm going to be explaining it. Actually, and it's exactly what zero. That's exactly what it is, and that's exactly what I would be doing here.
So if we talk about when you see 35, okay, that's a symbol for what? We have a polynomial where the 3 and the 5 are coefficients. So we have 3 times 10 to the first plus 5 times 10 to the 0, right? 0 in the base. We say 35 to base 10 is this value, right? This is the expression. So when you put a decimal point there, we were saying, well, I have 3 times 10 to the 0 plus 5 times 10 to the minus first.
Yeah, there's no fraction involved in any of this right here. This is all just literally you're taking a polynomial expression and you're taking the coefficients from it.
Yeah, so when you have digits, you need to know what base. And classically, usually the way people use it by default, the base is 10. But the base could be 8. The base could be could be pi, the base could be 2, whatever the thing is, right? And typically the digits are less than the base. I mean, the common way to express a digit is that you have between 0 up to the base minus 1. So if we're doing base 10, we typically deal with the coefficients being 0 to 9. But it's perfectly possible for you to say, instead of the digit 5, you could have the digit 4.5. And that would mean you have 4.5 times, kind of odd to write it that way, but those values, those digits, those are coefficients. Those coefficients could be, anything.
Yep. Sarah, you want to add anything to that real quick, or? Sarah?
Nope, I'm just listening at this point.
Okay.
So you gotta so that was why, I mean, it sounded like it was quibbling at the very beginning when he was talking about symbols, but I think that's part of where
I think it's a conceptual error. I think it's a major conceptual error that he's having, and I think this is an example of somebody that starts off with bad premises and just gets worse.
because one of the failings with common education of mathematics is people confuse arithmetic with mathematics.
Yeah.
Mathematicians use arithmetic sometimes, or often, maybe often, right? But arithmetic is not the sum total of mathematics. It sounded like at the very beginning he was confusing arithmetic with mathematics and symbols with values.
Yeah, I agree.
And alignment with and programming with equivalence, right? There are several things.
Yeah, I don't think he gets the concept of equivalence, or even like things like equivalent fractions and equivalency of how it's actually. People that have taken real analysis, they'll understand what I'm talking about. But there are ways of things talking about relationships and equivalency, and without an understanding of that, I think he's just thinking that these symbols mean something more than what they really mean, and what Lan is pointing out. Those numbers in a number literally are just those coefficients of that polynomial. That's the way they should be thought of. But in arithmetic, they don't really obviously get into that portion of it very often.
So you have to also deal with notation, right? Because some people have, this 1, 2, 3, 4. In some parts of the world, that's equivalent to 1,234. Other parts of the world, that's 1.234.
Mm-hmm.
Right? Now, you've got to understand, you've got to have a common symbol set. And then those symbols represent values. In this particular case, the comma there is for convenience purposes. And so oftentimes when you talk about technical paper, you try to avoid saying 1, 2, 3, 4, because some people, their default comma is the point between the ones and the tenths, or whatever the base is. And other people think it as groupings.
Yep. See, we use it as grouping, obviously. Okay, so he says values are placed on the position of the numeral relative to the decimal point.
Okay, well, they're not placed.
Yeah, I don't know what he means by placed.
Interpret points. Again, if you represent the reals as a line, you can represent the integers or the subset of the reals as points on the line. They'll be commonly when you express them, you commonly put them in linear order. However, if I can have a line that's logarithmic, in which case they aren't going to be equally spaced. They're going to be bunched up if I talk about the integers.
Yep. Yeah, that's a good point. You can do different scales. Like a logarithmic scale clearly is not going to be equidistant from each other. They're going to be completely. They're going to be. You can tell that they're going to be more compact on one side, and it's down. It's going to get longer away from each other.
You might say you can think of the integers mapping, or integers, a subset of reals mapped onto a line where the integers are equally spaced. You consider that. That's a way of representing that.
And then he says the whole number is greater than a tenth, hundredth, thousandth of a number. Well, it depends. I mean, the whole number 1 is like less than like 1 and 1/10, obviously. But if you did, obviously, if he's just talking about 1/10, then the whole number is going to be greater than that. But
yeah, but if he's going to say the 1/1000th of any number, 1/1000th of a large enough number will always be bigger than 1.
right,
So the verbiage that he's using there is not only confusing, but arguably it's just flat out wrong.
Yeah.
exactly. And the number 0.9 repeating is a fraction less than the whole with a value less than 1. Well, again,
Okay.
it's clearly
It's a
that's not a
decimal.
fraction. It's
It's
a
a decimal,
decimal.
though. It's not a fraction.
It's called an infinite repeating decimal.
Yes, and a decimal is the coefficients of a polynomial, right? This is not a fraction.
Not a fraction.
Now, because part of the thing, and oftentimes I think, and I get this with programmers as well, where you talk about a floating point number, and you talk about the fractional part of the floating point number and the integer part of the floating point number, or a calculator expressed in that way. But that's a function that's representing things as opposed to.
Yeah, I understand when a programmer does that. You're a programmer, but you make the distinction between when you program in actual mathematics. But I can understand a programmer saying, "Hey, I'm going to take, like, if I have 9.999, I'll separate the 9 and the 0.99. The 0.99 is the fractional representation that should be added to that 9 to make it 9.999, which is actually equal to 10. But that's still not a fraction. Fractional and fraction are not the same terms to me.
Yes. So you can describe a mathematical function that will remove that will map a value onto the 0 to 1 space, right? Like, if you will, in using programmer's term, throwing away the whole part and leaving the stuff behind. But remember, when you're using computers, computers don't use real numbers as well. Computers use a particular notation, integer or floating point notation.
And let me make it clear in the live chat, especially if you write these things, be sure you don't forget the ellipses, because if you forget the ellipses, you're wrong.
Yeah, so that's why it's dot, right?
The dot, or you can put a little r, or you can put a bar over the top you want to be repeated. Any of those do the same thing.
But it kind of depends upon your notation, right? So some people do 0, 9 with a bar, right? Saying.
I prefer bar, but unfortunately, it's a lot more difficult to use, right? In typing things out.
There's also notations where bar in Boolean logic means something, or bar in physics means something. So it kind of depends upon.
Yeah, like H bar means reduced Planck's constant. It's completely different than if you see Planck's constant, it means a specific value. But if you see H bar, that means this has been reduced. I think it's just division by 2, isn't it?
2 pi.
2 pi. Yeah, I'm sorry, 2 pi. Yeah, reduced by 2 pi. So H would be H divided by 2 pi, which is reduced Planck's constant. But that doesn't mean repeating. So these symbols do mean different things in different.
Yeah, but again, back to these are
fields.
These are symbols representing values, right? And understand it's perfectly permissible to have 2 symbols be the same value, right? Because you can say 1 plus 1 equals 2. We have a symbol, 1 plus 1, a symbol 2. They're the same value, right? It's perfectly okay to have more than one symbol for a value.
Continuing on, comparing 2 numbers requires a value to be placed on those 2 numbers. Again, they're not placing the values on the numbers. The numbers are the numbers are representing positions or coefficients.
So when it says comparing 2 numbers, do you suppose he's saying comparing 2 decimal representations of a value?
Let's assume for right now, I guess. Therefore, one has a value greater than a fraction such as 0.9, which is defined as the number 9 repeated indefinitely following the period.
Therefore,
I don't know how to parse that.
So he says comparing 2 numbers requires a value to be placed on those 2 numbers.
So you have 2 numbers, okay, 0.9 repeating and 1. He's thinking that they have values placed upon them, which I disagree with. They're representing coefficients, or they're representing places on the number line. The problem that he's having in this particular thing is 0.9 repeating and 1 represent the exact same position on that real number line. They are the same coefficient of the polynomial.
Yeah, so he said, but he says, therefore, one has a value greater than a fraction. Well, he's trying to say all fractions. First of all, he doesn't know what a fraction is. He doesn't know what notation is.
No.
He's saying that 0.099 is a fraction, which is always less than a whole. But wholes, for example, the fraction 3/2 is greater than 1, right? 1.5 is another way of representing that 3.5, right?
Yep.
So,
But one's in fractional notation, the other's in decimal notation. That one's an improper fraction, which is fine. But the other one, 1.5 is not a fraction. It is a decimal.
yeah. So if you
Right?
consider the real, if you let's say for sake of argument, we restrict ourselves to the reals between 0 and 1, right? So we'll exclude all values and just consider the reals between 0 and 1 inclusive, right? What he's trying to say is, well, therefore 1 is greater than 0.99999, right? No, because you got to understand what this 0.99999 out infinity represents. It represents coefficients of an infinitely long polynomial.
Which we will get into, and I actually have that.
Yeah.
I'll explain that. The number one is 1.0 ... Okay, they're equal, which is one followed by a period and then zeros indefinitely. Remember that numbers are only symbols, not an expression or a function. Okay.
Well, remember that when you made your statements back.
Yeah, I don't know. Yeah, he goes from this nonsense here to something he actually gets right. So I don't know. Algebra contains the concept of symbols and the ability to process equations by performing the same operation on both sides of the equation.
Well, it can. Algebra can involve those things, but
You don't have to. If you balance an equation, if you do one thing on the left hand side, you do it on the right hand side, but you don't have to do that in some algebra. I mean,
Yeah.
I mean,
you can build axiomatic systems where the equivalency is one way.
yeah, they're like, for example, even
Abstract algebra, right?
yeah, well, you can actually and you can actually have things where like commutativity doesn't hold. You can have things where different A times B is the same as B times A, but in certain types of structures that you can form, that doesn't have to hold true. The way you do multiply it can make a difference. It's all how you set up your axioms to begin with.
So I don't think he understands just how broad the term algebra is, or algebraic, right? Those are things. I think he probably, when he says algebra, he probably is using arithmetic operations.
Yeah. And by the way, let me note, this guy thinks that he's really good at math. I mean, he claims to, like, I don't know, tutor or something. I mean, I don't know what the hell, but it's just like, no.
But understand that there's a lot of teachers, unfortunately, who are bad at math that teach arithmetic to students and disable the mathematicians by boring them with doing stupid arithmetic. Right?
Yeah.
It might be cute to show someone how to do long division, but to spend months and months doing long division is a good way to piss someone off, not to teach them mathematical concepts.
I agree. Matter of fact, I not only hate long division, I hated synthetic division. That was my bane. Nobody, who the hell wants to do synthetic division? It should be banned from all courses. It sucks. Come on.
Now, I will have to say it's ironic because one of the things that we're trying to do here in our research is to use graphic processors to do long division, effectively long division, efficiently, right? And long division turns out to be actually quite hard to do efficiently.
Yeah.
In a highly parallel processing system. So
you're gonna be the person that actually solves P equals NP. I'm telling you.
Well,
All right. You don't think so? I think you can do it.
I don't know. If you ask me to take a bet, I think I would say it's likely that this century, the question about P and NP will be
Well, this century has a long ways to go.
understanding about that statement.
Yeah, we'll be dead by then. This results in a proof of two numbers being equal by the following expression: x equals y, and x minus y equals 0. Okay, if they're equal, then if you subtract from the other, you get 0. Therefore, we know that two numbers have the same value when they cancel each other out by the difference equaling to 0. The difference between 0.99 repeating and 0.0 repeating is not 0, therefore they're not equal. Well, here's the problem. It is 0. Matter of fact, in the reals, because of the Archimedean principle, there is no infinitesimals in the real other than 0. And I've asked him, what is the difference between 0.9 repeating, or 1 and 1? What is 1 minus 0.9 repeating? No answer. He just says it's not a 0. That's not an answer, right? I mean, if I say 1 minus x is 0.9 repeating, what is x? Solve for x. He can't do it. He says they're not 0. Well, yes, it's 0. They are the same number. They have the same value. They're equal. So x minus y here, if x is 0.9 repeating and y is 1, is 0.
Right. So we have an infinite sum. This is another way of saying. So we're summing from n equals 0 to infinity of 10 to the minus n. This has, you can show this by taking the limit is 1.
Yeah.
Actually,
well, I have it written down. It's actually the n has to start at 1 for that to work. By the way, yeah, that's your index system. Your index is 1 to infinity.
Sorry. Yeah. So n equals 1 to infinity. Sorry about that.
Yeah. Let me just quickly show these real quick. Well, you know what? I'll get to these real quick. So let me go through his thing first.
But that's an example. So, and understand when you're talking mathematics, you say therefore, you better have. You just don't say therefore because you want it to be. And mathematics therefore has a very specific meaning, right? You haven't proved anything. You haven't even established a proof. You haven't even established the statement, let alone gone through the logic rules to prove the statement.
Let's check this. Using algebra, x equals 0.9 repeating, y equals 1.0. These expressions are definitions. No, they're not definitions. That's not what a definition means. And those are not expressions. Those are equations. An expression doesn't have an equal sign. So, I mean, if the guy is like into math and he doesn't know the difference between an equation and expression, it's a little disconcerting because these are not expressions.
Yeah, and I'm now in programming, you would call those expressions. But maybe this is I don't know.
Well, I to be fair, I know he does do programming. I know he works with computers, but that's no excuse. He's not talking about computers here. We're talking about mathematics.
Yeah, and by the way, computers do not perform addition on the real number line or on the integers, right? Computers perform these really funny operations on rings, right? Because about overflow and floating point normalization and all kinds of other stuff. It turns out to be when you try to mathematically describe what a computer does in adding two real numbers together, two floating point numbers together, using like IEEE, it becomes actually a fairly complex mathematical operation.
Oh, I don't miss those days. I mean, I programmed a little bit back in the days, only like assembly type stuff, and back then it was only like 8-bit or 16-bit architecture, and what the hell was a double point string thing? They didn't have those things back then. The registers on the 8086 were all
so on a 16-bit operation,
or 8-bit, were they? They were 8-bit on 8086.
Oh, it's an 8-bit operation. On the 8-bit operation, 255 plus 1 is 0.
Because the 256 equals 0.
Notice I didn't say equals. I said is.
Is, yeah, okay.
Because
it's 0 to 255.
The addition operation in an ALU is not mathematical addition. It's within you have to define it as adding the values modulo the 256. If you're talking about just so-called computer integer math.
Yeah, that's when you have to use your mod function to actually figure a lot of that stuff out.
Yeah.
Okay, so if you say a number is 1, write the number 1. If it's less than 1, write a fraction, such as 0.9 repeating. Basic definitions. Again, no. Landon, please explain to this gentleman, this really clueless gentleman, that 0.9 repeating is not a freaking fraction.
Yeah, it's not a fraction, it's a polynomial, representation of polynomial. And in fact, again, well, I did a compact form here, but a way to think about this stuff is, way to think about this thing, it's 9 times 10 to the minus first, plus 9 times 10 to the minus second, plus 9 times 10 to the minus third, plus da, 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 right? Is that polynomial? It's a polynomial infinite number of terms. That's what that dot 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 means, right? Right. So each of these digits are digits of a coefficient.
And by the way, somebody noticed the mistake in your math, and I noticed this now too. Your summation, that would be for 0.111. You would have to. It's the summation of 9 over 10 to the negative n.
Oh, I'm sorry. You're right. Thank you very much. See.
I just noticed for 0 pointed it out. Then I'm like, wait a minute. Yeah, actually, it has to be 9 over 10 to the negative n. And then if you
forgot the 9 in front,
or you can carry it over. Yeah. So that makes more sense because before it's 0.1 repeating, because the fraction you're looking at is 9/10 because with a common ratio of 1/10 for like a geometric progression.
Actually, because actually without that 9, this value is here. This is really 1 over 9.
And did you notice that he, instead of putting 9 over 110, he just drew the 9 across the summation and multiply it, which is exactly the same thing.
Yeah, that's another.
So without the 9, you here we go. Yeah.
Or you could do 9 times this.
Or well, it'd be.
Right, because you could take this thing and say 9 times blah, right? If you want to do that one. Because -1 would be 0.9 plus 0.9, 0.09 plus 0. I mean, this is going to be 0.9.
No, it's well. Oh, I see. Oh, I got it. Because you have it as 10 to raise to the negative n, right?
Yeah.
Okay. Because the way I write it is 9 divided by 10 raised to the n.
Yeah.
Which is the same thing. That's how I write it. That's why I'm looking at it kind of weird. 9 divided by 10 raised to the n is the same thing as saying 9 times 10 raised to the negative n.
By the way, the person who caught the error, you get a point.
Yes, very good. I was staring at that too, and I was like, that is looking kind of weird because I have the actual math to show you, and I'm like, that doesn't look right to me, but I couldn't place it. So thank you, Zero.
But see, again, this is not an opinion. I was wrong, and when I saw the error, I corrected it.
Yeah, notice that's what an actual mathematician does, because we all, screw up stuff. Yeah. They don't sit there and go, oh shit, I have to like cover this up. It's like, oh no, okay, made a mistake.
Boy, say I'm right, well, because blah blah blah, and you can't trigger me. So yeah, this is different ways of expressing this sort of same polynomial.
Yeah, the bottom one is going to be a series that you add together, and I'm going to explain the difference between a series and a sequence too. And by the way, thank you for the super chat. By the way, Steven's had a super chat too. I think I missed it. But it was something along the lines of Steve is great. Steve is great. Steve is great. I don't remember what the hell you said there, Brian. I'll wait about the end.
My error, by the way.
That was 0132132.
Ah, excellent. Next
he knows math.
In the chat, I will give you another compliment for catching my error.
And Athena, goddess of wisdom and warfare, $5. If only Ronnie was here to help out. I mean, after all, I got into calculus. You know what? Yeah, you know what? He's off the internet, I guess. Him and G-Man decided to do what's best for everybody and just leave. But yeah, I don't know what's worse, listening to Ronnie pontificate on topics he's absolutely clueless on, or this guy Neoicon Mint making these really basic mistakes. But anyways, moving on. The error in the following incorrect proof is that when you multiply both sides by 10 times 9.9 repeating, the result is 10 equals 9.9 repeating. Well, actually, if you take 0.9 repeating and you times it by 10, you get 9.9 repeating. You just move the decimal place over 1. There's an infinite number of 9s, and so you don't lose out on a 9. You literally are just moving the decimal place by 1 position, which is anytime you multiply by 10, that's what you do.
Yeah.
So he says that, which is incorrect because both sides results in 0.1 equals 0.09. No, it doesn't. No, it doesn't. X equals 0.9 repeating. If you times each side by x, or so by 10, you get 10x, and then you have 9.9 repeating. Then if you subtract the original value of x, which is 0.9 repeating, you end up with 9x equals 9, and then you divide each side by 9, you get 1. X equals 1. That's the standard proof that's used to show that this is correct.
Because if you're going to multiply this both sides by 10, this 1 turns into a 10. This turns into 9.99999. Right? That's the.
Okay, so next one. Let's see here. So, which is incorrect. Dividing at 0.1 equals 0.09, which is again incorrect because the 0 in the position right of the decimal point can and needs to be changed by incrementing 0.1 by adding a number. Since counting is taking the number 9, adding 1 results in 10. The same applies to 0.09. Needs another count to get to 0.01 period. What the fuck does that even mean?
I think he's saying that when you add to this 9 becomes a 10.
Yeah, but he's using the word when you count to this, which I know that pretty much most of my issue with this is going to be verbiage, but there's a lot of verbal problems here.
And that's part of the problem, is that you're mathematically incorrect, right? You
can say it. He's mathematically challenged on this.
I think von Neumann would say you're living in a mathematical state of sin.
Using basic definitions of fractions, which he gets wrong, meaning going back and confirming our conclusion, we know that a fraction such as 1 over 1 and 2 over 1, which are both improper fractions, have the value of 1 because the numbers are equal, meaning both are a minimum odd or minimum even. Now, the reason why we say that 1 divided by 1 and 2 divided by 2 are equivalents because they're equivalent fractions, and equivalent fractions are actually set up in real analytics. There's actually a big thing on what it takes to make equivalent fractions, if I'm not mistaken. And so just when you have these really simple things like 1 divided by 1 equals 2 divided by 2, you learn those things early on, but you never really learn the reasoning why those are equivalent fractions unless you take some actually much more advanced math classes. You won't even learn even calculus about equivalent fractions. I didn't. I had to learn all that on my own.
So that last sentence in that paragraph is
this one
wrong.
Well, this one?
Yeah.
Yeah. Well, I mean, I'm fine with that.
Comparing.
Yeah. I mean, you always try to reduce it down, and you always have your
But when he says comparing blah 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 with the next sentence.
Comparing 1.0 with 0.9 confirms that the numerator and denominator of the fraction are not both even or odd. Okay.
So I think he's trying to say,
I can't parse that, so I don't know.
That's why I say I think it's not even wrong. It's just not well sort of.
In summary, the number 0.9 repeating is less than 1, which we will show you all why it's not. The two numbers are not equal, proven by the underlying concepts of math, which you do not understand.
Concepts don't prove.
Yeah, exactly. That's a good point. Concepts don't prove shit. You need an actual proof.
Yeah.
Not to mention he's wrong on two ways. One, this is why he's not even wrong, I guess. But one, the concepts don't prove anything. Two, he doesn't know what the fuck the concepts are. I don't know what the fuck the concepts are.
Yeah, good point. I mean, I think he's wrong multiple levels because he's appealing to concepts, and one, concepts do not make a proof, and two, he's conceptually wrong.
Yeah, and his terms are wrong, and his verbiage is wrong, and his foundations of math are incorrect. I mean, it's.
But Landon, when you count 9 onto 1, don't you get 10? That's how you're supposed to word that, right?
I think that's what he's trying to think. I think he's talking about counting as opposed to.
Yeah, well, I mean, maybe he's talking the difference between ordinal and cardinal. Like, for example, ordinal on top and normally you would have an ordinal on top and cardinal on the bottom, if I remember correctly. Is that right?
Yeah.
So I always get those confused, but I'm pretty sure it's ordinal on top, cardinal on the bottom. But yeah, because that makes sense because you're say like 1 divided by 5 or 2 divided by 5 or 3 divided by 5, 4 divided by 5, 5 divided by 5. The bottom are your cardinals and the tops are the ordinalities.
Yeah.
So that's what I think he's trying to say is there's a difference between the top and the bottom between a denominator and numerator, but I've always learned that as a difference between an ordinal and a cardinal.
Yes.
But I don't think he understands that. The two numbers are okay. So a change of rules and expression and values of numerals within numbers must be introduced for these numbers to be possibly equal. The number 0.9 repeating is close to 1, but less than 1. No, there's nothing needs to be changed, and we'll get into that exactly right now, I think. It's funny is if you ever really actually got into more advanced maths I never got into, I just tertiary and have a knowledge of things dealing with hyperreals and things dealing with surreals and things dealing with neighborhoods. There's some fascinating stuff to be talked about with that. I don't understand it. It's well beyond my ability. But if you guys ever get into like neighborhoods, it is what it means. Something similar, like close to the number, but not the number. But I don't know how to explain neighborhoods. What's the best way to explain neighborhood? It's so bizarre to me to even think about the concept of a neighborhood in math.
Roles, that sort of thing. But yeah, well, I mean, we're going off.
All right, we're going off a tangent. That's complicated.
I think the thing that, assuming this person didn't make a mistake in their document, I think what it suggests to me is they don't understand the difference between arithmetic and mathematics. They don't understand the difference between integers, decimal notation, and values. They certainly don't understand proofs because they've been using therefore and haven't been proving anything. And those are some pretty damning things. I would hope for charity purposes they simply made some errors in their document. But
that's how I started with this. I thought I was giving principle of charity, but he's adamant that I'm just fundamentally flawed, that he keeps calling me ignorant and an idiot and I'm a mathematical moron. Now you're an expert in mathematics. You're one of the leading experts in mathematics. I mean,
there's lots of mathematics I'm not an expert in. So
no, but specific types. I mean, primes are your thing.
Yes. So
I mean, they're probably. Who on the planet knows prime numbers better than you?
Well, I mean,
very few.
It depends on there because there are some people that are working on like twin prime stuff and Goldbach conjecture stuff. Those are areas. There's lots of stuff in primes that I'm not into. But if you talk about calculating or constructing proofs for primality, I'm pretty good.
Yeah, you were like I said, you're the number one expert in calculating proofs for that. But based upon your experience with me and what you've read on this guy, again, I'm not trying to toot my own horn, but I'm going to. Who at least has a more basic understanding of some of these principles, him or I?
And your concepts are sound.
Right? I'll take that. That's good.
Very relatively cringe-free. So
I appreciate that. That's high praise from Landon, actually.
I'm not trying to be cute. I mean, cringe-free says that an expert doesn't have that much to quibble about. And when you say not even wrong, that's the worst statement.
Oh, that's horrible. Yeah, and he is not even wrong on this stuff, I think. I call that fractally wrong. Okay, so let's look at this. Can you see what I'm posting here? These are some things I did in Wolfram Alpha. Okay, Wolfram Alpha will check these things for you. And I asked him numerous times. I've given him proofs. I've given the geometric proof. I've given the algebraic proof. I've even given calculus proofs. And you can validate them with Wolfram Alpha, which is a great computational program. Now, granted, sometimes you have to fiddle with Wolfram Alpha to kind of get it to understand your syntax because the way certain things are written in it, and I get that. So you may think that it might be perfect as written, but Wolfram Alpha may not like it. So you have to fiddle with it a little bit, maybe use some parentheses or just restate it in a different way. But this particular thing here, this is actually showing that this is a true statement. This is not rounding. This is not a calculator error. By the way, calculators, correct me if I'm wrong, but they use like some kind of Newton method for calculations most of the time.
And again, their computers are doing representations of a ring, not the real number line, let alone any arbitrary integer. And notice in here, this equal sign is not an assignment. The expression you see is true or false, right? When you say foo equals bar in math, that's either a true statement or a false statement, assuming it's math.
It's going to be a bivalence, right? It's going to be either one or the other.
Yeah.
So this is actually asking and evaluated: are these two things equal? It's not asking are they close. It's not asking if they're um, two different. It basically is asking is it two different numbers.
So a value, if you have an expression of value equals value, that expression is either true or false. If I say fluffy bunny equals 3, that's not even wrong.
Right. Purple equals 2 is not even wrong.
Well, purple is 3, so sorry.
Purple's 4. Okay. Yeah. So this is a perfect example of evidence, right? When we talk about evidence, clearly in the types of fields that we talk about a lot with science, evidence is what is going to make the hypothesis more likely. But in math, something like this is a proof. Well, this is not okay. I should say this isn't a proof, but this is evidence that shows the equalities are the same here.
You haven't proven.
I haven't proven it. Yeah.
You type that string in, it'll say false, or it will say, become a Patreon.
There you go. Exactly. So I did exactly what Landon did. I started this way, and I was showing that each one of these things is basically just a number added to another number added to another number based upon 10 raised to some value. Okay, that's going to be what's called a series, and then you get an infinite series, right? This is exactly what Landon here. If you guys can see, this is why it didn't look right, because he has it as 10 to the n, which is fine. I think he started index wrong initially, but 9 times 10 to the negative n. I usually write this as 10 divided by 10 to the nth. It's the same thing. So that's why we noticed. That's why Zero noticed that this 9 was conspicuously missing from that. And then you can draw this 9 across the summation and put it out here. That's what you want. So
in the talking and didn't pay attention as much as there, but again, kudos the ones we do for showing the error.
But you notice that you have exactly what the Wolfram Alpha has. I mean, there's no difference between what you wrote and what the infinite sum is, showing that we have an understanding of what actually is happening here.
Yeah.
And then you can actually break it down what's called the partial sum formula. And the partial sum formula will give you an individual number based upon where you want to start the index. Your index, and the people that don't know math, this symbol here, this sigma here, it means summation.
Yeah.
And the bottom here, n equals 1, is where you would start the index, and the top is where you end the index.
Over the integer, assumed to be over the integers.
You usually do it over the I usually do it over the natural numbers, but because n to me, I always consider n to be, if I say n equals 1, to me, I always thought that assumed to be natural numbers. Now, I don't know if that's a hard set rule in mathematics, but every time I've ever seen n used as the variable for the indices, that's always been for natural numbers. Is that true?
Conventions, right? It's
what?
Conventions there. I mean, when you're dealing a number theory and do a probability test, usually P is means prime, but again, it doesn't have to be, right?
Okay, so there's no set rule on it, but generally n is going to be natural numbers or positive integers.
Yep.
Okay, and so you can use this formula here to determine what you would have at a specific index. Like if you wanted to add n equals 1 to n equals 2, or you just want to go n equals 2. So if you just plug a number in there, like this one, I just plugged 1 in. What is that summation going to be? Just with the numeric value of 1 in the n variable over here, that's going to be 9/10, right?
Yeah.
Okay. So let me blow this up for you. So the partial summation formula will give you your summation of the whole thing between a range or a specific value of the indices, where you don't have to do a full infinite summation. So it works. So moving on. The whole formula, this is what I think it's Zero asked about the limits. One way a repeating decimal is defined, not just expressed, but defined to be, is the limit as something approaches x, I use k, with the summation of the series as n equals 1 to k. And if you type this into Wolfram Alpha, it shows this is true. This is actually something that actually is a relationship that holds true. He doesn't think that this is correct, and yet math, obviously, if this was not true, Wolfram Alpha would say false.
Right. That's one of the ways to do it. 9 times, I make sure we're doing it correctly, the limit as k approaches infinity of the summation from 1 to k, 9 times 1 to k of 10 to the minus n.
Yes, and by the way, I should note that it's small n. I think Brian Stevens points out n was the factorial of a non-negative integer, and denoted by n factorial is the product of all positive integers less than or equal to n. Yeah, capital N and small n, I have noticed is a difference as well. When I was learning how to construct a number by using a Cauchy sequence, n and small n mean two different things.
Yeah. So let me make this. Actually, can you see? Let me make this bigger so that people can see it better. So again, we're talking about the limit as k approaches infinity of the summation, and I'll use your notation, n equals 1 to k of 9 times 10 to the minus n. Is that, or do you want 9 over?
It doesn't matter. You can do it either way. It makes no difference to me.
So that is 1. The limit of that. Of those
Yeah, that's how repeating decimal is defined as.
Yeah.
That whole thing.
Yeah.
And basically,
for infinite sum. This is also a case.
the reason I think it's important to add that limit is that the way a series, and we'll explain the difference. Put a series and a sequence on it so we can explain the difference real quick. Because he has a series on the bottom, 0.9 plus 0.09 plus 009. That's a series, but a sequence would be 0.9, comma 0.99, comma 0.999, comma 0.999 plus ... That would be a sequence. And so what this limit is saying is that what a series converges upon, what a sequence converges upon, is by definition the limit of that sequence. So 0.9 plus 0.99 plus 0.99 ... If that converges upon 1, that is by definition the limit of the sequence.
Right?
Yes, that's a sequence.
Right here. This is a sequence out here. So you can see that, right? And again, one of the things to understand, when you're doing work on things, and a colleague comes by and says, "Oh, I think that should be that sign is wrong, or you made a mistake there," then you go and fix it, right? This is sort of the one important thing is that you will make mistakes, and you have peers review your stuff and say, "Well, what about blah? What about blah? What about blah?" Right? And you get it to the point where but one important thing is to admit when you're wrong and to fix it.
I don't think he's going to. I mean, I'm sure he's going to watch this and he's just going to think we're all idiots, including you. So
I made a mistake initially because I had it as 0, and I made a mistake because I had the 9. But I looked at it and said, "Yeah, that's right," and fixed it. Right. So.
Okay, and so we also typed in here: is 0.99 repeating a whole number? Result: 0.99 repeating, or 0.9 bar, is a whole number. It is a whole number. It's not a fraction. It is a whole number. It's just represented differently than we would normally express a whole number to be. But it still is a whole number. Just like cosine 0 is a whole number. It's 1.
Well, I mean, whole numbers typically you're talking about are integers, right? Is one of the things is that what you say is that whole number is an integer. It's usually the term, and so yes, that's it.
And we can type that in too. Actually, it'll actually do that as well. Is 0.99 an integer? It comes back yes.
Right now, what part of what it's doing is that really what you're saying is the value of this symbol an integer, a member of the set of integers. Yeah.
Right, and that has to be. We're talking about the value itself, not the representation.
Yeah. So is the value of this representation a element of the set of integers? Is probably the more proper term to way to say it. We say, what is a whole number? A whole number is a value who is a member of the set of integers.
Right, and that value is in the set of reals, the set of integers, the set of whole numbers. It's also in the set of. See, I actually did real numbers. It's also a set in the complex numbers. 0.99 repeating is a complex number.
Yeah. And the symbols are, again, you got to think about these decimal representation are really coefficients of a polynomial, and you can generalize these coefficients to have different values. So for example, by convention, when we talk about decimals, we put in symbols 0 to 9, but you can put into that place a number that's not an integer or a number that's greater than the base. What do I mean by that? If I have a number 1 and 12, if that's my representation, what does that mean? That means 1 times 10 to the first plus 12 times 10 to the 0. Now we typically what we call normalize, where we carry the 1 and we turn that into this. Right? These digits are a representation of a polynomial, and this 2 times 10 to the first plus 2 times 10 to the 0, this is the same as that. The two polynomials are equivalent. These two values are so now it looks odd for you to give you a decimal number where one of the digits is greater than the base, but it's perfectly valid.
And people are just tripping in your whiteboard. Yes, this whole wall is his whiteboard.
Yeah, we when you come to these rooms, we talk and argue and do all kinds of stuff about stuff. We have to have lots of space because you never have enough whiteboards to do things.
And one last thing, 1 minus 0.9 repeating equals, what is it? What does it say, sirs? What is that result?
Looks like 0.
Looks like 0.
Yeah, 1 minus 0.9 repeating would be 0 because the numbers are, I don't know whether it's equal.
Yeah.
So let's look at this, and this is a bigger argument I think to be had from this, and this is what I brought up to Reds when I was on Red's channel earlier. Flat earthers are stupid. This is call it what it is. Flat earthers are dumb. Now, I think that somebody who denies math, that denies proofs, that denies Wolfram Alpha, that denies things that can actually be proven, unlike things that you can't prove the shape of the earth. You can give evidence for it, and you can overwhelmingly say that it's far more likely that this shape is this other than that, but you don't prove existential things. You don't prove scientific claims. Math you can prove. So I think there's an argument to be had, and I don't know if I'm actually making this argument because there's overwhelmingly different things that you can bring into the variables here, but I think to deny math like this is somebody that has to be dumber than a flat earther. Now think about that, because here you have somebody who denies proofs. The one thing that we can actually show in the world to be categorically true is mathematical proofs once they're proven. So what do you guys think of that argument?
Say that again.
The argument I'm submitting, and again, I'm not actually really maybe advocating this because there's so many different variables here, but flat earthers are stupid. But
yes.
To deny math, such to the point where you're denying a proof, that to me is dumber than a flat earther, because he is actually saying that math is wrong. He is saying that all math is wrong. He has the right math, even though I've quoted him many, many different textbooks. I've shown him many different proofs, including geometric progression, algebraic, calculus. By the way, the geometric proof is a really good proof as well, if you guys haven't seen that.
So Steve, can I ask you if you catch a bit of irony here? What did he type this up on?
He didn't. I don't know. He that was an instant message to me. I just copied and pasted.
Well, it doesn't matter what it is. Everything he types it up on ultimately will essentially be a computer of some sort, correct?
Yeah, that uses the exact same maths that we're talking about. Yeah.
And if he were to try to program a computer using his particular type of mathematical logic, the computer would not run.
Yeah.
Except
it simply would not function.
Well, the only difference is that, like he said, it runs on rings, but not the number line. But yeah.
Of course, the other bit now, computers can do algebraic manipulations, right? And for example, I have a program called Calc, and it is a calculator that calculates in rationals and complex rationals. So I can represent 1/3 on the computer exactly because I represent tuples. When Calc deals with a value, it represents a value A and a value B. It always handles the fraction.
I remember tuples from a long time ago, but
So when in calc, when you say 1/3, it can absolutely on a computer represent 1/3 exactly, because it has two integers, 1 and a 3, and it understands that the pair, you divide one or the other to get the value, right, for that.
but it treats it, but that would treat it as 1/3 as a single unit.
Yeah, so calc has rationals and it does math on rationals. So when you add two values together, you're actually adding the fractions, right? And doing the, you're doing the stuff when you say 1/3 plus 1/2, it will go through, put them into a common denominator and give you your numerator.
So if I like added 1/2, it doesn't have to convert that to decimal and go 0.5 plus 0.5 equals 1.
It'll end up with 2 halves, and then it'll reduce that to 1.
Yeah. So okay. So let's say I had like 1/3 plus 1/3. It'll actually show it as 2/3.
Yes.
Okay.
And 1/3 times 3, it'll be 3/3, which will reduce the fraction to 1.
Yeah, that's pretty cool actually, because most programs obviously won't do that. They'll convert it to some kind of decimal. They won't treat it as a rational.
What's really gets thing is when you have something like computing hyperbolic cotangent using rationals, right? That's it gets really, but again.
Yeah, let's not talk about inverse hyperbolic functions and stuff.
Other things also to understand is that, I made 2 mistakes in here, and at least, and people pointed out and I corrected it. That's an important part of math. You're fallible, but math isn't. That's a really important, let me say it again. You're fallible, but math isn't.
Yeah, and let's look at this proof real quick. Like, this is the geometric proof, right? This is exactly what we started with. We have the same series you had. 0.99 repeating is just the summation of 0.9 plus 0.09 plus 0.009, which it can be written out this way, with the plus point dot dot dot. If you put this into Wolfram Alpha, it's going to say it's true, right? Derek says, this has been fun. I would carefully say 0.99 is an integer. There's no integer 0.99 in the integers, but equivalent to the one of the reals miraculously. Yeah, no, we're talking about the values. I understand there's equivalent classes here. There's a distinction between 0.999 as far as being a rational number as opposed to being an integer from the representation, but they are equivalent in dealing with equivalent classes. That's what I'm trying to say.
Yeah. I mean, and I'm trying not to be mean to the person and have some suggestions. One of the things I would suggest is study what mathematical proofs are, right? Don't assume you understand, but study proofs if you want to because that's proofs are a deep part of what mathematicians are involved in. Secondly, understand when you're wrong. Collaborate with people and correct your mistakes. I mean, a very famous example, about Fermat's last theorem.
Sure.
And Andrew Wiles came up with his paper was modular elliptic curves and Fermat's last theorem. But he published that, and Taylor proved that there were certain certain conditions that were not met. And so Taylor worked with Andrew Wiles and corrected the proof, and now it stands. And that's the problem. So it actually is the Taylor-Wiles proof. They both get credit for solving it because, and again, Wiles was not, was willing to have someone point out a mistake in his proof, and then that person helped Wiles fix it, and the two co-authored and are the credits for having the first successful proof. So if you're wrong, if someone points out you're wrong, learn from the mistake, correct it, and move on. Don't sit there and dogmatically say, da, 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 right?
Yeah, I think that's the takeaway from all this. Look at, we all get shit wrong sometimes. I'm corrected quite often in the live chat, and then I'm like, okay, I'll accept that, or I'll be like, no, I don't think you're right, or I just think you're an idiot. But we all don't mind when we actually have an actual mistake. My reasoning is this: You come out to me with a good argument, I'm going to listen. You come out with a great argument, I'm probably going to change my mind. You come out to me with a shit argument, I'm probably going to block you. Okay, it's just or ignore you. I don't waste my time with things that we know are demonstrably false. This is an exception because we know this is demonstrably false, but I think it's a good learning experience for this very reason. Is that when you have somebody this practically wrong, you are dealing with somebody who's literally no different than a creationist in that regard, right? Because a creationist is going to start with young creationism cannot be wrong, or a presuppositionist that starts with the position that God has to exist as a necessary precondition for intelligibility or metaphysical necessity. All these people start with a position that cannot be changed, and that to me is not how you go into a conversation.
Yeah, and that's kind of the thing. And notice I made two mistakes. They're corrected. I saw it and corrected it.
And he's one of the smartest people on the planet. So
that's
but mistakes creep in.
You don't assume you're right. You learn, right? And that's the thing. So these presuppositional stuff, where I guess he's presupposing certain things about notation and so forth. There, these presuppositional problems. The big problem with presupposition is it requires you to commit intellectual suicide.
I agree.
I would actually say that presuppositionalism, especially when it comes to something that has hard proofs that work against your presuppositions, I would say that it's a form of arrogance, honestly.
Well, like Sai has this weird notion that precept, if you start with a precept, you can't be wrong. I don't know where he gets that from.
But you can be wrong, because if you have a presupposition that is demonstrably wrong, beginning with it doesn't make it more right. It's still demonstrably wrong.
But he doesn't get that concept. He's like, this is my presupposition, and that presupposition cannot be an error because it's a presupposition.
I presuppose that the Earth is flat. The Earth is flat can never be an error because it is a presupposition. That demonstrates why that's fallacious.
And it sort of is. But again, in my opinion, Saitin committed intellectual suicide somewhere in around 2002, where he says he discovered this thing, and it gets worse under the sham of being polite. It engages in really dishonest and disrespectful rhetoric, right?
Well, he's one of the last that uses it. If you haven't noticed, I don't know if you guys really paid attention to presuppositional argumentation when it first came on the scene a few years back, but it was everywhere. It was ubiquitous. You couldn't go in our hangout where somebody wasn't trying to run a precept script.
Yeah, and that sort of is the thing. So but anyway, again, I think because and what do you mean by intellectual suicide? You've essentially destroyed your ability to learn. You've destroyed your ability to think. That's what it means. That's it's worse than you're just wrong on this thing or I disagree. It's you have essentially destroyed your ability to understand and reason. So and I think where arrogance comes in is when someone presuppositionally then tries to use some sort of erudite and pseudo-polite statements, when in fact they're saying you're fundamentally wrong. I mean, one of the real weird things that presupposition people do is assume that truth can be boiled down to some phrase.
Right, they don't understand the complexity of truth. It's not as easy as people think.
But that's where some of these folks that are presuppositional have a religious bent go wrong, where they take some book out, some phrase out of the Bible or the Quran or Bhagavad Gita or something L. Ron Hubbard said or something that Joseph Smith wrote or whatever. That's what they start with, and they say that's right, and then drive from it, and you can't really reason from there. And then if they do it in the form of being erudite and polite, they have the audacity to assume that God is only truth, and that those that don't fit their definition are awfully wrong.
Well, that's actually something that and Steve can attest that if this is actually on the same topic, but it's something that I kind of talked about in my last video. I pointed out that if you have a belief and then there's reality, and there's a portion of reality that's demonstrable. So, for instance, evolution was my example. If there's a portion of reality that's demonstrable, and your issue is squaring it with your beliefs, one of those two things is in fact malleable, and the other is not. And the
Yes.
belief is always the thing that is malleable. Reality is not. If you want to say I believe I can fly, and then you jump off of a bridge and find out very quickly you can't, your belief is going to have to change really quick.
Yeah,
Well,
and real quick,
that's the essence of intellectual suicide.
Dan, did you watch Cy and Raoul on Non Sequitur the other night?
I have not yet watched that.
Okay, you watch it, especially watch near the end. I don't know how many minutes into it. It's probably a good 90 minutes into it. I actually engaged Cy for about 3 minutes, and I've been told by more than one person that 3 minutes basically destroyed him more than the entire rest of the conversation that was being had. And one of the things that I had brought up was that one, he posits God as the metaphysical necessity, but then you ask him to prove that and give reason why he has to be a metaphysical necessity. He can't do that. But more importantly, when it comes to the things of truth, what's that, Pam? Was that Pam?
Sorry.
Okay.
It was Pam. Because you kind of called me when I wasn't really prepared. Me and Pam were playing video games on the couch, so I've been muting myself during the interims.
Sorry.
Oh, no worries, no worries. No, it's cool.
Go
Play
ahead.
your game. Play a game. And so, he asked somebody what the definition of truth was, and this is when he was talking to RJ. Actually, this was doing debate roulette where we had 3 people come in and talk to Cy, and one of them was RJ, and he couldn't give a well-defined definition of truth. And I think it is very hard to give a well-defined definition of truth, but it's a lot more complicated than just saying what corresponds with reality. That's a very basal, superficial working definition,
Yeah.
but it's not exhaustive at all. Because if you're talking about truth, for one, I don't even use that definition. To me, truth is something that has a corresponding fact that is attached to it, based upon what are called truth makers. And the concept of truth makers can be very complicated. There's many different types of truth makers. Something makes something a necessity. Something makes it based upon numerous different factors what a truth maker can be. So the concept of truth, what is true, is not as cut and dry as people think. And what he tries to do is he tries to distill it down to some very simplistic thing. What is true? Well, that you could spend an entire college course on what is true and still not really have a great understanding, to me, what it means to be true.
I have a lot more respect for truth than to assume that I can state truth in one little statement or phrase. But Cy has the audacity to assume that, because God is only truth, anyone that claims that they cannot come up with a definition of truth that doesn't fit his God assumption must be wrong.
Well, they're basically gonna do the thing.
Suicide includes this arrogant assumption that whatever you might think is wrong with the Bible is your fault, because he declares God as his axiom of truth. And forced in a corner, he'll play games like, say, I will only do Bible studies with Christians, or babble, or you're in no position to judge God, or you don't have a simple definition.
That's all rhetoric.
Yeah,
That's
that's
just
literally
pure
all just using word games, and none of that has and I know that it's when I'm saying it's using word games, I'm not saying it's the same thing as when somebody who doesn't understand philosophy says, "Oh, that's word salad." That's literally just word games. It's putting yourself into a position that you think is stronger by reinforcing your position with nothing more than verbiage.
Yeah.
When you say things like, "Who are you to judge God?" You can't say that because God. Whenever you do things like that, that's not really philosophy. That's literally just using words to artificially create a stronger position when the position wasn't strong to begin with.
And I think it undermines your position when you do that. But people are asking what truth makers. A truth maker example, like they call it like virtue, virtue T, which would be a truth maker is that which is in virtue of something being true, or an entailment truth maker. Truth maker is a thing that is this very existence of which it entails that something is true. So if it exists, it means it's true. Virtue T would be in virtue that is something is true. There's all the different ways of expressing what is true by truth making properties. And when Cy tries to get somebody to say, what do you mean by truth? I can spend a long time talking about that, and it wouldn't get us anywhere, because as Landon correctly points out, Cy has committed intellectual suicide. He doesn't want to learn what a truth maker is. He doesn't want to learn the difference between correspondence theory and coherent theory of truth or anything like that.
That's the difference between legitimately wanting productive discourse and having an agenda.
Yeah. So I say, don't waste your time talking to Cy. because he appears to be a man who's killed his mind long ago. And so I know Sai's out there, and he's trying through some of his other folks to get me to debate him.
No.
You're not even worth this amount of time. But back, so stepping away from Sai and talking about just the general thing, I think it's always it's very important to be in a position to be potentially wrong, see your errors, and correct.
You see, before you got to the see your errors and correct, I said, oh, a position that's always potentially wrong. Well, we do have flat earthers.
Yeah, but that's the thing that you should do, rather than just hold to your dogma and say, but I'm right because blah, right? The same thing, the same game can be played for people who say, well, the earth is round because the earth is round, right? Prove it. Why did I go through the efforts of measuring the size of the earth, measuring the distance to the moon, measuring the distance to the sun, measuring the distance to the planets, nearby stars, Why did I do that? Because I wanted to build it, I wanted to construct it, and I also wanted to see it, and because it was a lot of fun, right? I think it's actually fun to go through and test these things rather than just assume the earth is round. Prove it, right? And you can prove it. You can do that.
Well, I disagree with that. I hate the word proof when it comes to things like science. You don't prove the earth is round. What you can do is you can make a highly probabilistic argument that is much more likely the case, almost to the point of being obscene, not accept, because we can definitely demonstrate the earth is round and show that it is, but I never use the word proof when it comes to science.
So notice something I'm doing here. Steve's right. I made a mistake. Let me correct myself. You can measure within a certain error these things. That's what I should have said. You see, when you do something wrong and someone points it out, you learn.
Well, I don't think you did anything wrong. I mean, there's people use the word proof colloquially, and I get that. It's not exactly right or wrong, because again, I don't think these words have intrinsic meanings. They're just usages. But I personally avoid using the word proof, although colloquially it's acceptable, I guess.
Distance to the sun within a certain margin of error.
Yeah, I mean, like I explained, like the age of the earth, we can't be certain that is 0.54 billion years, plus or minus 20 years. And yes, I do use the phrase epistemic certainty. Somebody bitched at me about that, but I have a reason why I use epistemic certainty, because there's a difference between epistemic certainty and psychological certainty. So when I use that, I mean that very specifically. And if they don't like that phrase being used, tough shit. But what's more likely, the earth, based upon all the evidence we have, all the conciliation of all the data we have, that is somewhere around 4.5 billion or 2 weeks old? What's more likely the range is going to fall in?
Yeah. Now, there's error involved in that age estimate. Also, the other thing is that the formation of the earth was not a one-time event.
Right. That's why it's over a range. Yeah.
People,
but it wasn't 2 weeks ago.
Earth was formed over a period of time. So one of the things you have to talk about when you say how old is the earth is you say, well, when was it earth? And when was it proto-earth?
Yeah, and that goes, back to whole when do we first call it Earth? But still, we know it's well over 4 billion years. That much is a given, right? I mean, when you start getting down to this specific range, it's more difficult.
Yeah, you get more. When you get more precise, you can't sit there and say the Earth was formed on Tuesday, right?
Right.
You can't get that because again, the formation of the Earth occurred over time. So you'd have to come up with some kind of definition where you say, oh, now it's Earth, right? Before it. Almost there, and now it's Earth, right?
Unless you're Usher, because he said it was like Tuesday morning at 9 o'clock or something. Yeah.
But 9 o'clock, which time zone?
I don't know. He didn't say, but I'm pretty sure that's what he said. I think it was on a Tuesday at 9 a.m. He didn't give the time zone though.
Yeah. So and so you measure these things and you demonstrate things, and you can show the Earth is a spheroid.
Right.
And you can measure the curvature and you can measure the distance of things. And it's actually quite fun to do that sort of thing. I mean, it was in the case of how far is the sun. I mean, literally that was the first complete sentence I spoke as a human being was how far is the sun, right? That shows I was a little less than 2 years old, and I went on a 30, 40-year quest to answer that question, which was done by myself. I was up in the Arcetri Observatory in Florence, above Florence, Italy, and a colleague was in Madagascar, and we observed the transit of Venus. We used the initial method that Newton and Halley came up with that was attempted by a guy named Cook, and was attempted by some people in the 1800s. They had problems with measurements. They had problems with the atmosphere of Venus, but we counted for that stuff and got an error that was actually quite small. By the way, there's other ways to measure the disk of the sun besides transit of Venus, but that was one of the satisfying things, because historically that was something.
My daughter was when she was in 5th grade, I was helping her with some stuff, and she was actually doing, believe it or not, box plots. Yeah, and dealing with error range and things like that. I was like, this was 5th grade. I'm like, that's awesome, because I don't remember doing box plots in 5th grade, because she's in a STEM school, and they really focus on math and sciences, and I think that's awesome that they're learning things like that at a much younger age, because most people have never been exposed to a box plot and more or less taught it in 4th grade. But real quickly, somebody in the live chat, they're talking about point nine repeating. Point nine repeating is not an infinite number. That's a common mistake. It is a very finite number. It exists between other real finite numbers. Like, for example, if you take the range.
That series, that limit converges. It doesn't diverge.
Yeah, well, any sequence that's going to converge on a specific number, right? That limit of that sequence is the convergence if it doesn't diverge. But 0.99 repeating, that is a converging upon 1 by the infinite sequence that we showed earlier, right? So yeah. 0.99 repeating is an infinite sequence. It's better expressed as an infinite decimal expansion, but it's still a finite number, because if you have the range 0 to like 2, right? Its existence is somewhere in between them. If it was infinite, it would be outside that range.
Yeah. So
and reals don't allow for infinite numbers.
The integers diverges.
The integers as a set would diverge. Yeah.
Yes.
Unless you're doing a Riemann summation.
Notice I was very careful. But yes, because you can quibble and say.
Yeah, you could use what's called analytical continuation. Yeah. And that's where they get the 1 plus 2 plus 3 plus 4 equals negative 1/2, or it's to be negative 1/12. But that's using a specific type of summation called how do you pronounce the name? Ramanujan?
Yes.
It's not a Riemann summation. It's a
Ramanujan.
Ramanujan, yeah, Ramanujan summation. But then when you do a Ramanujan summation, though, you should put that R, that fancy looking R. That way, you've used a different type of analytical continuation to do that.
Yeah, but I said it diverges. I didn't say it was infinite. I didn't say it was infinity. I said it diverges. That's the proper.
Yeah.
The proper thing. So again, it's one of the important things about learning is dialogue with people, listen to what they have to say, correcting your mistakes, and moving on. And that's what I hope this person does. I'm not trying to pick on you. We're not trying to, I mean, personally not. Maybe other people are, but I'm not trying to.
No, but being wrong is the first step to learning, and learning is one of the first steps to actually being right. You can't learn anything if you aren't wrong first. So being wrong is not a bad thing. Being ignorant is not a bad thing. Being ignorant doesn't make you stupid. It's not a pejorative.
Yeah, and being arrogantly wrong. I mean, when this guy is telling me that I'm wrong and every PhD is wrong, and it's like that's when it's borderline.
Well, again, that's arrogance, though. That's arrogant. That's when you've got the person who's done no study in a particular field and says that they know more than the experts in the field. That's arrogance. We also call that flat earthers and young earth creationists. But it's literally just flat out arrogance. But that's not the same thing as simply being wrong. I think people have a really hard time, and I think both of you probably would agree with me. People have a really tough time with being wrong because there's like a level of anxiety with being wrong. Like around your peers, you can be kind of wrong, but around your betters, you feel a sort of pressure to be right because you want to be with the other people who are right. But when you're demonstrated to be wrong, you feel shut down instead of feeling motivated to learn why you were wrong.
Yes,
correct.
One of the flaws of things like social media, like Twitter, right? that when you're wrong, people go, ha, 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 type of thing. That's admitting you don't know or discovering you don't know is a critical step to understanding. Right? So when science discovers something unexpected and realizes we don't know, we get really excited, not because there's something to learn, right? And in fact, if you look at the history, for example, of Newtonian mechanics and Newton's laws of motion, so forth, it seemed pretty solid, and there were people who were arrogant enough to say Newton's stuff is truth. And then in the 1800s, particularly towards the mid or latter part of 1800s, there were some problems that Newtonian mechanics wasn't doing well with, and now the assumption was, well, there might be some measurement error, or there may be something we don't quite understand, and Newton's laws will work out. But we eventually the nail in the coffin was Einstein and Edekind's proof and so forth, where we said, okay, we now really understand something, and we learned from that thing, and we moved on. Now, Newton's Newtonian mechanics is pretty good for everyday stuff, but we now know that that Newton's laws do not perfectly describe everything.
Right. And real quick, Oshkosh, but Josh, no. There are such things as infinite numbers, by the way, but 0.99 I'm repeating is not infinite number. Infinite numbers deal with ordinalities and cardinalities and all these weird types of conjectures and shit that well-ordering principles, stuff I never get into. That Landon would have to explain all that crap, because I still don't understand the well-ordering principle, and I've tried to wrap my head around it many times. But because there's an old joke, the joke like a well-ordering principles, something lemma. What's that mathematics joke? It's basically a different way expressing like the same thing for the densities of the reals. But these are hard things to wrap your heads around, and I'm not very good at those concepts. So that is my limitations. I can't explain those things very well.
Because, for example, you could have conceptually an hotel with an infinite number of rooms where every room is
Hotel
occupied, and then someone could show up and you can fit them in the room.
Yeah, that's Hilbert's paradox of the Grand Hotel. That I do understand, that kind of stuff.
That's an example where you have to start dealing with things carefully and not use these sort of naive assumptions, right? And so that's part of the thing in understanding those sorts of areas. So again, it's really important to learn. I think that's and it's important to be corrected, and it's important to move on and refine. That's how.
Yeah, my conceptual errors. I always have a hard time with mapping when it comes to isomorphics and bijections and surjections, especially like when you're talking about well ordering being like isomorphic to like a unique ordinal. I don't know how to interpret those types of things. I know what they are. I mean, conceptually, kind of, sort of, but when you're dealing with cardinalities and even Cantor's like diagonal proof, those are hard things to wrap your head around when you have different degrees of infinity. You have finite numbers and infinite numbers, and I don't have the brain power to think on that type of level.
Yeah, there's a lot of mathematics can become very abstract.
Very abstract.
Specialize in things like infinities and some of that work, and it's a fascinating stuff. Problem is there's too much stuff to become an expert in everything and focus on everything. So you just take it one step at a time. And I mean, I'm quite fascinated with computational mathematics, because computers are these flawed, fallible things, and mathematics and to explore mathematics with flawed calculating systems is a really interesting and difficult problem. What do I mean by flawed? Computers are pieces of hardware that make mistakes, and you can't make mistakes in mathematics and have a useful result. So if you're using computers to do calculations, you have to check that you try to check that calculation is correct. And I mean, example is your typical, your typical CPU that Intel sells has a kind of a mean time to error where every once in a while it will miscalculate due to electrical fluctuations, due to radioactive particle decays, contaminants, cosmic rays, those sorts of things, right? And so if you want to use computers to do something, and it's something that's not trivial, that's going to take many computers thousands of hours, you have to deal with the fact that the thing is going to make mistakes. Just like if you're going to send spacecraft out to a remote planet, you have to build into the spacecraft not only fault tolerance, but fault resilience. And so but here's the thing that I was taught. A slow, correct answer is infinitely preferable to a fast, incorrect answer.
Oh, yeah. Yeah, and they've come a long way in error corrections in computers, have they not? And to try to eliminating kind of that kind of stuff.
But we have. I mean, one of the notorious things is NVIDIA GPUs are really lousy calculators. They make errors all the time.
Mm-hmm.
Most of the time, people use GPUs. They don't care because you might have the error might be that a pixel on one screen refresh might be a little bit more green than it's supposed to be. Or it makes an error where someone's doing Bitcoin mining and it misses a value, right? That people don't care about that. But if you want to use GPUs to actually do stuff that's correct, that's mathematically useful, it becomes quite difficult.
Well, they're just gonna have to get quantum computing down to an art form one of these days.
That would, of course, that's going to be even harder to.
Yeah, I would think that it's harder to keep a quantum state than it would be something along the lines of how memory is stored in a computer. I mean, in a quantum thing, those things can easily be changed their quantum bit state by any kind of just cosmic ray or something.
And error correction. I mean, one of the things we were doing, we're also working on machines to do very large integer factor. And the kind of things, we're talking about machines that consume many megawatts of power and run over a long period of time. And what you find is that memory becomes a really difficult thing to trust, because over that size, that amount of data, that amount of time, memory corrupts, even if error correction, because there are ways you can change memory and have the polynomial still think it's good.
Mm-hmm.
So you end up having to do lots of things to try to minimize that error by storing it in multiple places and doing all kinds of stuff, right? It's computers are ultimately fairly flawed, and but an operating system you're running is actually, you can have lots of errors. An operating system will continue to stumble on. But when you're trying to do a mathematical proof using that involve calculations computers doing, it becomes quite tricky.
Yeah, speaking of operating systems, somebody later on get with me. I'm at my wit's end. I got to figure out how to put my Grub 2 loader back on. I changed my motherboard, and my motherboard says it has SSE3, even though it's a Phenom, but it's a Phenom 2 AMD, and it should work just fine. But I can't load into my OS on my hard drive for my Linux. I have two Linux. I have the Mint, and I have a Studio. I don't care much about the Mint, but I do want the Studio. So if somebody really, really good at Linux boot ups, I've tried everything, literally every software out there. Hit me up later, but I got to start wrapping this up. It is getting late.
We should talk some point, see, because there are ways to get around that kind of stuff.
I've tried everything. I'm usually pretty decent in it, and I've just thrown my hands up in the air because ever since I replaced my motherboard, I can't get my Linux to run, and I really miss my Linux. I use it for certain things. It runs faster than Windows, and it's just smooth. I like it. But anyways,
there's certainly help for that.
All right. Well, maybe we can get with me later. If anybody has suggestions for what we might be doing on DEF CON 1 Science, let me know as well. I wouldn't mind doing something eventually on combinatorials, maybe, or I don't know. Landon's probably not going to be available this weekend. I think I have somebody coming in. I don't know. Are you available this weekend? I don't remember.
I think there's isn't someone else doing something this weekend?
Well, I have Dr. Jack Kroon coming in, but I don't think he's going to be available to after September, second week of September or so. He wanted to do something earlier, but his bosses got on him, and he has to wait till he's getting a new job. So.
Yeah, I understand that boss thing. Sometimes it's hard.
Yeah, dude, he was just mentioned in a tweet, and they lost their minds. Yeah, I mean, he didn't get any trouble, especially because they know he's leaving, but they just want to make sure he didn't divulge any classified information relating to his job, which is not a secret. I mean, it's out there that he works for the Naval Observatory. But okay, there's a Linux kernel author, though. Yeah, so Andrew, if anybody knows about how to do this, it's going to be Andrew. So yeah, I'll ping him on G+. Thanks, Andrew.
So yeah, there are things that, I mean, we run into this notion with stubborn nodes that lose their grubness.
Yeah, I'll get both of you together and between the three of us, because I really, really do want my grub working, but I want to be able to obviously boot into Windows 10 too. So
yeah, and those are certainly
it's weird though. This it doesn't have EFI. It says that it's EFI, but when you go into like Windows and you go into troubleshooting, there's usually a UEFI window that comes up, and there's nothing for that on Windows 10 for my computer.
There in Windows operating system installers that end up smashing. Basically, they make the presumption that they're the only thing on the system.
Yeah, and I hate that.
And stomp on things.
Yeah, it's very Windows centric.
And so that may be part of the problem, is that so I've seen things where what we've done with operating systems like that is you install that operating system first, and then you whack the bootloader and move things around. But that's or you run on a virtual machine or blah blah. But
I don't like running on a virtual machine because it just does not run as fast as native. Sure. It just doesn't, and I noticed the difference. Yeah, I think I did kill the UEFI partition, but it says I have a UEFI partition, so I don't know why it's not recognizing.
Ways you can rescue that stuff as well. So
yeah, I mean, like I said, I've been through all this. I went to the BIOS. The BIOS has nothing to turn safe boot off, although I did through Windows. I did turn off the restore. I turned off the hibernate. I basically anything I can force it to do to force it to run off the UEFI partition. I've tried. I can run it off a stick, but I don't want to run off a stick either. So we'll get in the next couple of days or so. I'll get with you guys. But any guys have any questions on this? Message me. Just do a quick just survey. So what do you guys think? Do you guys think that Neoicon Mint is practically wrong, conceptually wrong, in error, not correct? Any of the above, or do you think that Landon, myself, Cyrus, every PhD in mathematics I know, Wolfram Alfram, every college textbook I've ever read on repeating decimals, rational numbers, etc., are wrong? Which one are you going to go with? I'm just curious. That's what they say. They say he's not even wrong. Yeah, that kind of sums it up.
And again, and also again, know the value of making a mistake or you don't know. That's the beginning of knowledge, right? It's a thing. You look at someone like Dr. Traylor. She'll say what she knows, and she will be willing to be corrected, assuming your correction is correct. And she'll say what she doesn't know. Right? That's the kind of the.
Oh yeah, I noticed that, and yet, like I said, I mean, I said something, she explained and corrected me, and I'm like, okay, fuck, yeah, you're right. Okay, I mean, I don't mind. I don't mind arguing with somebody if I really do think I'm right. I don't care if they have a PhD or not. People do make mistakes. But if you sit down and think about it and go, okay, here's a person who's really an expert in this field telling me I have an error here. Let me think about this before I make an ass of myself. Oh, shit, they're right. Yeah, that's how you should do it. That's how we all should do it. No matter what you know or what position you are. That's how a good skeptic should approach something is, you know what? Okay, let's analyze this. I may be wrong. I have every day. I have Twitter dumpster fires, and maybe you guys are seeing some of these, where I go out and point out people that are so dogmatic and so much of an ideologue, whether they're a creationist or atheist, that are willing to deny things like logic. Like the last dumpster fire I started was I happened to tell somebody that the Kalam cosmological argument is a logical argument. It's logically valid. And people lost their shit. And to the point where they're denying modus ponens, saying that's not always logically valid. I'm like, you people have lost your fucking minds at this point.
Yeah. And by the way, Steve, on this question of atheism versus agnosticism, I think philosophically you are correct.
Why, thank you.
But the question is being philosophically correct useful?
Yeah, no, there's a different argument to be had. I mean, I'm the first to admit that I'm for the normalization of atheism, right?
Yeah.
And I understand why people use the terminology they do in order to achieve that. I get that. That's a pragmatic approach, and I'm a pragmatist as well. So I understand that. I don't take offense to that. What I take offense is when people say things along the lines of, this is the only case, Steve. There's no other way. This is the only definition. This is the only correct definition. There's no such thing in philosophy. And as you recognize, philosophy, I am correct in it. I can validate it many different ways, but that's only in the realm of philosophy, right? And so I am the first to admit you can use other definitions, and you take the baggage that come along with it, and you can want to normalize atheism. I get that, but my only argument is, don't tell me, not you specifically, but people out there, don't tell me what definition I should use when I'm using correct definitions to begin with, right?
Isn't it really strange that you'll have somebody say that, oh, your definition has to be mine, but then in the same breath they'll say that, well, my definition, my label is atheist because I'm trying to normalize it. Because you're trying to normalize something does not change the actual hard definition of that. You can take the label, but you can't say my label is incredibly subjective and I'm admitting it, and I'm also saying your label must be my label, even though my label is subjective.
Yeah, and also the fact that I'm not telling people what labels to use, yet they tell me what label to use, right? They're always trying to get me to adopt that label of atheist. And yet I don't care what label they use. That's the difference. I'm not telling them they have to use a certain definition. And yes, in philosophy, it is ubiquitous. There are other definitions. There's multiple definitions. I can think 3 or 4 off the top of my head. But if you look at any philosophical paper, atheism is always going to be the belief. It's always going to be the positive.
Should I actually do a video on this at some point, Steve?
Yeah, I mean, there might be minor exceptions. I mean, obviously Anthony Flew, 1972, George Smith, 1974. Those, I mean, if you read his book, I haven't read it. I read it a long time ago. The Case Against God by Smith, I believe it was published in 1974. That book is horrible. It's just so bad. Just read the first chapter or two, and it's all Anthony Flews type argumentation back in the 70s, right? So, I mean, there are books out there. That's not a peer-reviewed book, by the way. There are non-philosophical sources, like textbooks that people, not textbooks, personal books that people write that would probably not have that, like I said, Smith or Flew, but for the most part, But anyways, I think the point is, I don't tell people what to use. Stop telling me what to use. When I say that I'm agnostic, I'm agnostic. There's a reason for that. It's not the same as atheist. I'm neither an atheist nor a theist. Get used to it. And anybody who says that you have to be one or the other, you're an idiot. Straight up idiot. There's no other way to describe it.
What you've done is when someone says, "Are you an atheist?" I have to say, "I don't know."
Well, yeah, that's not unreasonable, right? I mean, because you say, well, I don't know. It depends what you mean by atheist, right? That was Burton Russell's thing when he wrote, "Am I an agnostic or an atheist?" Depending on where he would go, these things meant different things. So he was like, "What am I?" So
yeah, and that's sort of is where I'm at right now, which is I don't know, but
yeah, but you do agree with this. According to philosophy, according to the definitions that are common, the ones I use, it makes sense logically to say that I'm neither theist nor atheist. That's not an illogical statement, because some people say that you must be one or the other. Those people are just wrong, fundamentally wrong. Would you agree on that?
Mm-hmm. Yes. I mean,
okay.
I think that's I don't think that's a defensible statement.
I agree. Sturgis agrees with that too. That's why he considers himself to be a colloquial atheist, philosophical agnostic. And I think that's the perfect way of putting it. I still like that a lot. Yeah, you could do a video on that. Yeah, and by the way, thanks for the shout out on that last video you did. I did watch it, of course. I do admit I watched Sirius's stuff. Fuck, I can't.
I mean, it's probably a bad habit of yours.
I can't help it, man. But yeah, no, like I said, I thought you did a brilliant job on relating Clifford's principle You related it exceptionally well, very, very easy to understand. I think honestly, you did a much better job than I could have ever done. So,
Well, I think
good.
the thing that I realized is that there's not. So the ethics of belief has chapters upon mind-numbing chapters, and God damn it, Steve, if you make me read that shit again,
It is
swear to
mind
God,
numbing. I know. I'm not.
I
No joke,
the,
right?
but the ethics of belief can be boiled down pretty easily after going through all that literature. But I figured that one of the easiest ways to relay it was something that most atheists and skeptics and theists already understand pretty well, which is Pascal's wager, because it's been done to death. So I was like, okay, well, Pascal's wager the original version of Pascal's wager, not the modern version, factors into Clifford's principle really well. These two things can probably be worked together to make it a lot easier to understand, because one of these is already well understood.
Yes.
Didn't Pascal, say more than just the trivial wager that people colloquially call Pascal's wager? I mean, he actually was.
His original form was not the modern false dichotomy that we usually see now, where it's, oh, there's these four scenarios. His original form was essentially a method of shaping your own psychology. It was a method of changing your habits of thinking so that you would eventually believe something.
Yeah, the way Pascal, he recognized that people can't really force their beliefs, right? You can't say I believe myself I can fly, right? He accepted I would think doxastic involuntarism. So his was a methodology to over a period of time convince yourself to have the belief that God exists. Why that God would require that, I don't know. I don't understand the narrative that God is so petty that you actually have to convince yourself to believe something just to avoid some kind of eternal punishment.
It's why the way that I worded it was that you're dishonestly hedging a bet. That's really all you're doing with either the modern or the original version of Pascal's wager. You are dishonestly hedging a bet, and that's why Clifford's principle applies, because Clifford's principle literally states there's an honest way to come to your belief, and there's a dishonest way to come to your belief. And the other principle is it's incredibly dishonest to reject evidence that directly goes against your belief.
But you don't accept Clifford's principle, do you? Because I reject Clifford's principle. You do know that, right?
It's not something that I necessarily accept, because when you're dealing with Clifford's principle, it's like almost anything in philosophy, it's a very useful tool.
The problem with it is that it only accounts for evidentialism. You can have pragmatic or prudential reasons.
Well, yeah, pragmatism and presuppositionalism and all of that, none of that falls under Clifford's principle.
Yes,
Clifford's principle deals with evidentialism insofar as it's only dealing with what evidence is there that leads you to a particular belief.
Yeah, so it shits all over pragmatist.
But and I'm a pragmatist, so you know that causes issues.
Yeah, most people. There's three ways. Three most common things: being an evidentialist, a non-evidentialist, or what's called a moderate evidentialist. I would fall under non or moderate evidentialist, somewhere in that ballpark. I am not an evidentialist for that very reason, and that's why I think straight epistemology has issues, because it falls too far into evidentialism and empiricism. And it's useful for some things, but it's not. Like we saw, straight epistemology sucks for precept.
Well, yeah, it does. And that's one of the reasons why I think that Clifford's principle is a useful tool. But I would not say that it's an end-all be-all thing that I'm going to use in all conversations. But if I find that there's a conversation that it can be used for, I will use it, because I have a decent understanding of it now.
Yeah, well, there's a lot of things that are useful tools. I mean, like Newton's flaming sword is a useful tool, but I mean, reality is I reject that as well, but it still can be useful.
Yep.
You know, if you guys remember Newton's flaming sword, anybody?
Is folks learn and willing to make mistakes and be corrected and move on.
So let's end it with that. We appreciate you guys watching. Like I said, well, I don't know what we're going to be doing on DEF CON 1 this weekend. I'm not sure, but you know what, we'll figure out something. But anyways, tomorrow, what do we got on non sequitur? Let's look real quick before we end this. Let you guys know. We are booked till the end of October. Do you believe that? That's ridiculous. We have Planet 9 parallaxicality tomorrow. Interesting. And also, we also have I believe Red's Rhetoric is having a debate tomorrow too, I believe.
Who's doing the Planet 9 stuff?
I'm not sure who that is. Is that Coons? I don't know. I didn't set this one up, so
That's being done in this division of planetary science is the notion of search for planet 9 is considered to be kind of a well, it's defaming Clyde. I mean, searching for planet X is the proper historical term.
yeah, but that gets confused with Nibiru. We're going to be talking about actual planet 9 in the Kuiper Belt.
So you don't need to search for planet 9. It's called Pluto.
It's not a Pluto. That's not a planet. No, I was kidding. It is still. To me, it's a planet. It's a minor planet. Whatever. But yeah, I guess they're really talking about the unknown planet that's out there that's causing these perturbations.
That has been always called Planet X. Planet 9 appears to be one of the things that a couple of people are looking.
Oh, that's true, huh?
Are doing and searching. I think with particularly when LSST comes online, they'll probably put the nail in the coffin. The issue with the people that are searching for Planet X and make a claim to these orbits, and therefore it implies there's this massive planet out there, and they're searching for it, is that there are other explanations besides a massive planet that fit the data.
What could it be, a brown dwarf?
Well, one of the things in common we know are that stars pass near the sun. And there's going to be stars in the future that pass near the sun. I mean, one of the things that Gaia has given us is the ability to do some backtracking, and we can see, in fact, that there's a star that got within the or next to or slightly within the Oort cloud that would have sent stuff, all cockeyed. So there are other things that can explain than it, but the people who do Pluto Killer and Planet 9 have this sort of shtick that they're doing, which a number of people are kind of tired of. The question of, is there a unknown large planet out in the Kuiper Belt or beyond, which is causing some of these orbital anomalies? That's an interesting question. And unfortunately, we haven't discovered that yet. But even Tyson now is gradually admitting, yeah, okay, I guess Pluto could be a dwarf planet, and dwarf planets can be planets. Because he's wrong on that too. But that's a different story.
That's a whole different ballgame. But
so the thing I have to say is that I have a question, and is this notion of search for planet 9 historically, yes. When we knew Neptune and that was it, the search for planet 9 was something that Antalmon did, and he successfully found Pluto, and so that's there. And then the notion of, is there another planet? They called it Planet X.
So you're saying Nibiru exists then?
So
you heard it here. Landon believes Nibiru.
The search for Planet 9 is I think is a bad term.
Yeah, and I agree with you. I'll have to bring that up. We'll talk about that tomorrow. But anyways, Landon, always a pleasure, my friend. This is great. I think this was educational, informative, and if anybody still doesn't understand this, message us. But I think at this point that if a person just wants to reject this truism, they're just not rational at this point. It's the same thing. Put them up there with a flat earther, put them up there with a young earth creationist. They've, as Landon has so eloquently said, committed intellectual suicide at this point. So with that, you guys want to say goodnight? Anything you want to put out?
Keep exploring this wonderful universe. It's worth paying attention to.
Cirrus, your channel?
You can see my channel at youtube.com/Sirskeptic. I think I'm going to start doing a lot more philosophy videos on LHAC. It actually looks like through the polls that I put out that people are wanting to see more philosophy on my channel, which is really weird because I put up a question if you want to do philosophy or video responses, and a lot of people are leaning towards philosophy. It's weird.
Yeah, and it's so funny because we do have people that actually say philosophy is useless. And it's so funny because the people that I notice that say philosophy is useless are the ones that actually engage in it. They just don't realize it. It's weird. It's just weird.
And of course, if I were to plug someone, I go check out Milwaukee Atheists. They've got some interesting stuff going on.
All right. And with that, guys, we'll call tonight. Good night.